Heat shimmers above the plains. The air looks empty, but the ground hums with a tone too low for ordinary hearing. A family halts mid-step. Trunks lift to windless sky. Feet settle deeper into dust. A pulse arrives as pressure, then as meaning. Move now. Water there. Danger elsewhere. They answer without a sound the ear expects. Soft stamps, long breaths, the soil itself as a conduit. It is communication without a visible sender, a system older than the thorn trees, a kind of seismic talk, messages through the ground, carrying farther than any shout, and arriving when other signals have vanished. This landscape is built for distance. Open savanna, hardpan patches, braided riverbeds that flood and dry in long rhythms. Life here organizes around scarcity and memory. Herds split and fuse, travel hundreds of miles each year, and coordinate movement around resources that appear and disappear with the season. The social map is layered. Tight family cores, allied groups, and strangers who sometimes answer calls anyway. Only after sustained watching does the pattern resolve. These are elephants, cooperative strategists whose bonds endure for decades. Their survival strategies depend on keeping contact across kilometers, timing departures and reunions, and deciding when to stand and when to leave. The evergreen anchor of this story is simple and unsettling. Elephant seismic talk, messages through the ground, may be one of the least understood channels in a well-studied giant. Now the riddle. How do low-frequency calls couple into soil and stay intelligible over kilometers while resisting wind and terrain noise? Airborne calls drop below 20 Hz into infrasound and can travel tens of kilometers under stable conditions. Yet evidence suggests some portion of the energy leaves air and enters Earth, becoming surface waves that skim along the crust. Field recordings show vocal bursts lasting 2 to 8 seconds, sometimes repeated in trains with regular spacing, a timing that could encode identity or urgency. Trackers have watched herds align their bodies, still their breathing, and press their feet more firmly before a distant group arrives, often within minutes of the signal's origin. Surface, Rayleigh, waves in compacted soil can move around a few hundred meters per second, far faster than a walking pace, meaning a call sent from 5 kilometers, 3.1 miles, away could be felt in under half a minute. But soil is messy. Layers shift, moisture scatters energy, anthills, roots, and burrows break coherence. Intelligibility should collapse with distance. And yet, at times, it doesn't. Messages still arrive with enough fidelity to trigger coordinated travel, defensive clustering, or quiet feeding that resumes on cue. In a place where noise is constant, wind, insect swarms, hoofbeats, this persistence seems impossible to explain. Several mechanisms could be sharing the load. One hypothesis centers on dual-channel redundancy. Each long call radiates energy both in air and ground. The brain then integrates 2 versions of the same event, one through the ear as infrasound, the other through mechanoreceptors in the feet and trunk tip, improving detection the way 2 eyes improve depth judgment. Studies indicate specialized receptors in the foot's fatty pad can sense minute vibrations. The long limb bones act as conduits, passing signals toward the middle ear by bone conduction. Trade-off. Dual channels help detection, but divergence between air and ground paths could blur timing cues at range. A second hypothesis treats the Savanna like a stratified instrument. Hard pan layers, dry root mats, and crusted surfaces can guide surface waves, bending energy around obstacles and preserving a narrow band of frequencies. If true, the soil acts as a selective filter that favors the call's strongest harmonics while shedding noise. The cost is brittleness. After heavy rain or in deep sand, the guide may fail and range collapses. Scientists still debate how often real landscapes behave like tidy wave guides. A third idea is behavioral editing. Callers choose when and where to send. Many long-distance exchanges cluster at dawn and dusk, when winds are low and temperature gradients stabilize the near-surface air. Callers also stand on firmer ground, widen stance, and hold still, maximizing coupling. Receivers mirror the posture, reducing self-generated noise. Repetition and spacing of notes may carry identity and intent, allowing partial messages to be reassembled from fragments. The trade-off is time and exposure. Repeating calls can reveal location to rivals or predators, so timing becomes a strategic decision embedded in survival strategies. Add one social twist. Networks amplify physics. Large groups act like relays. A family that hears the first pulse may begin moving, and their movement, stamping, and additional rumbles emit new waves, refreshing the message downrange. What looks like improbable transmission over one great distance may often be a chain of short, reliable handoffs. It is elegant, if true, and it would be rewriting what we thought we knew about group coordination. Beyond the mechanics lies a question with teeth. If messages travel in earth as well as air, what else do they carry? Age, stress, confidence, a whisper of intent. The title returns to haunt the field notes. Elephant Seismic Talk, Messages Through the Ground, describes a channel that feels intimate and vast at once. Much remains untraceable, buried under hoofprints and heat haze. In a world getting louder, the quiet path may matter most. When the next dry year arrives and waterholes shrink, the ones that feel each other first may endure. The ground keeps a memory. Those who listen may find it. And yet nobody knows why some signals cross miles, while others die at the mound's edge. The mystery holds its line and keeps moving.